Hey guys, my name is Joshua Delahose. I'll be doing the first project of Fluent. Let's get started. We'll start off by going over to Fluid Flow Fluent, dragging it over. I'm going to right click on geometry, new design modeler geometry. Give it a second to load up. Alright, set it to normal to XY or normal to Z. Go over to sketch. I'm also going to change the units to millimeters. Go over to rectangle, draw a rectangle. We could add dimensions now. V1 we'll set to 10, and to make it simple I'll do 500. Generate it. And we're going to go over to concepts, surface from sketch, click over here. Click on that. Click apply on base objects. And then we're going to generate it. It should turn out gray. This is set up for like the mesh, or at least just for the shape, so that we can get onto the mesh. And once it generates, we can go back, double click on mesh, start the mesh process. Starting the mesh down here. Zoom out a little. You have your overall shape. Now we can start creating the mesh. And we're going to go over to mesh over here, right click on it. We're going to go to method. insert method. Click on the triangle, it's going to highlight green. And then we're going to hit geometry. Apply. And then generate that. These divisions, or not divisions, but the overall mesh shape. We'll go over here, insert sizing. Edge selection up here, and then we're going to hold down Control and then left click on the different sides, inlet and outlet. So we'll start with this side. That's the first one. And then apply. Actually, we gotta click that side too. Both sides. Apply the geometry. And then we look for element size. Number of divisions, we'll click 100. Capture curvature. Where is it? Right here. Hit no. Behavior, we're going to change that to hard. And then we could generate it. Cool, it's going to light up green. That's how you know you did the first part right. We can make sure by right clicking on mesh. And you have your overall mesh. We'll fix the inlet and the outlet. We're going to go right click on mesh again one more time. Insert sizing. And then go to edge selection one more time. And then we're going to do the top and the bottom this time. So Control and then left click over the top and the bottom. Both are green. You go over to geometry and hit apply. And then we're going to go over to type element. Where is it? Same thing, number of divisions. This time we're going to do 500. Capture curvature. We're going to hit no. Behavior is well hard, so behavior hard. Now we can generate that as well. place the divisions on top. We'll go over to mesh, right click on it. Now you can see all the division. It looks cleaner. Now we'll fix the inlet and the outlet so that it looks more uniform on the entrance and the out. So we'll go to edge selection. And then do inlet. So I just named the inlet doing that. Go over here. Press N again. Outlet. Top wall. Bottom wall. So you got inlet, outlet, top wall, and bottom wall. Cool. Now it's done. Oh, we forgot something. Clean up. We're gonna clean it up. Almost forgot. So right click on mesh. And then insert face meshing. Select the rectangle. And then apply geometry. And generate that. Right click on mesh. Cool. So it shows up all black, but that inserted the face meshing. We're done with that. We got the name selections over here. We can minimize this. And then we're gonna right click on mesh and update it. So check mark is good. We're good to go. Move over to setup. We're gonna double click on setup. Double precision. Make it go quicker, so I'll put a 4 solver process. And I will start it. Takes a little while for it to finish. It's loading up. finish loading. Okay, I think everything is done now. So this is the Fluent page where we'll be changing the cases and operating them. Alright. So under model, make sure everything is off. Go to viscous. Go to mode, select laminar. Close this out. Drop down materials. Fluid. Right click on air, edit. Density, we'll just do round it to 1. And this one we'll do 1e to the -4. Close it. Minimize materials. Boundary conditions. And we're going to go to inlet. Right click. Go to edit. And velocity magnitude, we'll put 10 meters per second. Apply. Close. Go to outlet. Prevent reverse flow. And hit apply. Close. Top wall. Put stationary. This is for the first case, so it stays still. On the next case it changes, it will be moving. This is for so the top wall can move, or actually so it could not move. The next one will be moving. So I think that's it for this setting. Yeah. Okay. Close. Minimize everything. Go to reference values and double click that. Compute from inlet. Keep the values. And initialization. We're going to double click it and it's going to run. calculations. We'll do 500. Alright, calculation complete. Go over here and go to vectors. Click on new. We're gonna name it velocity vectors. Compute. Say display. Close it. You can see it forming. We'll minimize this. And then go to results. Double click on results and let's see. I'm gonna go over to location. Where is it? Oh, there it is. We're going to create a line. This will be our midpoint line. Domains. 2 points. Point 1. We'll do 0.25. samples of that and hit apply. Another one. We're gonna do another line. This is the endpoint. All domains 2 point, and then this one we're gonna do 0.499. 0.49. Just before the edge. Do this one 0.01. Also 100 samples. Hit apply. Yep. We're gonna go over to contour. Name that a velocity contour. Change this. I'm going to change it to symmetry 1. A variable. Velocity u. Number of contours. 100. And apply that. Nice. Then go over here, change the contour, the legend, sorry, and title mode, we'll change that to variable. And click horizontal, and then we'll hit apply. Yep. And then go to appearance and change the size to 0.8 and a precision of 2. And then scientific, change that to fixed. And we're going to apply that. And that changes the legend. It looks neater now. Better to the eye. And then we're going to come over to the graphs. Or the chart. Click on that. We'll insert a chart and name that velocity profile chart. We'll hit OK on that. And we'll keep that to the XY line. And title, we'll name it velocity profile. to data series. Series 1. Location. Change that to midpoint. Then we'll name it midpoint. Endpoint. Go to the x-axis. And then change this to velocity u. Y-axis, we'll use the Y for the height. These are going to show the midpoint and endpoint velocity lines. So apply that. Nice, cool. So here it shows you the midpoint line that ends earlier than the endpoint line, right? You see how velocities form sooner at the midpoint than they do at the endpoint. You have two different velocities at each point. One is underdeveloped, the other one is more developed. The endpoint being more developed, right? So you can minimize this. I'll actually show you the other ones too. You can see where it enters and they're not as developed, and towards the midpoint they're developed but not as developed towards the end. That's why it shows you on that graph. So that's cool to see. Minimize this. And we can close the design modeling windows. And we'll move on to co-wet flow. The one that I showed you previously was Poisal flow. Now co-wet flow would be different because the top wall is going to be moving. So we'll go back to this one and go to models. Make sure laminar is still on. Everything else is off. Go down to materials. We're going to go right click on air. Edit. Velocity. We're going to change that to 0.01. Change create. And close. Bounding conditions. We're going to go over to inlet. Right click on inlet. Edit it. Type. Change that to keep these 0. And then we'll apply that. Close it. We're going to go over to the top wall. Edit. Change this to moving wall because now the top one is going to be moving. Speed, let's see. Change the speed to, let's do 10 meters per second. Apply. Close this. And then we're going to double click on reference values. We gotta make sure to change surface body to inlet, which it's already on inlet, so make sure it's on inlet. And then right click on run calculations and initialize and calculate. Form the lines. Back to workbook. I'm going to right click on results, update. Go back to post results. And now you see that the bottom one here's your endpoint and your midpoint. They're both on top of each other right now. So if I delete the endpoint, you'll see that the midpoint is the same linear velocity as the endpoint. And they should be on top of each other on this co-ed flow. So we'll add the other one back. Apply, and you see you have both of them. Endpoint is the same linear velocity as or velocity profile as your midpoint. We can go over to the viewer, and you see that the top wall is moving red, right? As the velocity increases, you have a red color. So your top wall is increasing velocity, is moving, and the bottom one is stationary. So you have a co-ed flow. Alright. So that was co-ed flow.